You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. This GraphRAG term has seemed to pop up in the current AI industry overnight. I want to discuss one perspective from a blog post on what it is and how it fits into the current tech landscape. Then I also read an interesting article on some ways to improve software development for hacking your brain and getting better solutions. The first thing I want to talk about today is what is GraphRAG. Now, Neo4j published a blog post a few weeks ago called the GraphRAG Manifesto, and I'll include a link for this in the show notes. I really thought it was a good overview of what is a graph, how it fits into AI retrieval augmented generation or RAG, and then how you can build and architect that system at a very high level that's easily understandable, I think, across different business roles and technical roles. The thing that this is founded upon is Google's 2012 paper called Introducing the Knowledge Graph. Things, not strings. And this is where Google search back in 2012 started using a knowledge graph or connected entities in order to improve the search results on kind of the Google search engine. We're going back to this now as we look at retrieval augmented generation and the field of artificial intelligence. However, traditional RAG is still approaching data as flat, not connected like a network. So it's going back to that strings aspect rather than things. GraphRAG can help you improve and get better results out of your AI systems, as well as give you explainability and auditability for your answers. This post walks through what is a graph. It's not a chart. It's a connected network of entities and data points. And then it looks a little bit at how do we represent knowledge? And there's a few different approaches to this, but it first compares what is a human representation of, for instance, an apple. The human representation of an apple is very complex, right? We can't really document that on paper. Then another knowledge representation of an apple is a vector representation. This is a string of numbers that represents different components or features that compile our understanding of an apple into a machine-readable representation of it. So it's this big string of numbers. Just looking at the string of numbers doesn't really tell us a whole lot. Then there's a graph representation. And depending on your context and the data you want to store, you can add a variety of different contexts based on what you choose to connect it to. For instance, an apple could be used for baking in these specific recipes. It could be this specific color. It could be related to the company and the logo, Apple Inc. It could be a variety of different things. And you can choose what to store and what data is related to it based on what that context is that you want it to be. So don't misunderstand the article. It does say that vector and graph are both very helpful solutions to retrieval augmented generation problems. And a lot of times using them in combination or using them both together creates a very powerful result in your AI applications. GraphRAG then is using vector search combined with retrieving context from a knowledge graph or that connected representation of entities. The post walks through a brief overview on the GraphRAG lifecycle, how you construct a GraphRAG solution, how you would create the knowledge graph that underpins all of that connected data, and then talks a little bit about why you would choose a GraphRAG solution. It's going to give you better accuracy, more useful answers, more context around how it got to this answer, as well as source information. However, as with most things, I do recommend you don't just take an article's word for it, especially one produced by a company who has a vested interest in that message. But I would definitely encourage you to use this as a data point, try it out for yourself, and see if GraphRAG could help you solve your business and technical problems. The next piece of content I want to look at is an article called Algorithms We Develop Software By. Now, this author looked at some different maybe just pieces of software methodologies for development and just compared and contrasted some different ways you can maybe hack your brain or hack your typical software development process. The author's friend gave his input on a method. You start writing a feature at the beginning of the day. If you don't finish, you erase it and start over the next day. You could keep your tests if you wanted. If you can't implement that feature after a few days, think about the building blocks that you might need to build it. For instance, boilerplate, connections, so on. And then build those different components or pieces, and then come back to that main feature later after you build those parts. And that would help you finish that feature faster. This concept is not new. Extreme programming had elements of this back in the 90s and 2000s. So this concept of write and rewrite is not new. The author makes the case, though, that he does something similar with junior programmers. Solve the problem, stash the code, and write it all again. The second time is going to take less time, and you often write much better code because you're reviewing the problem with a fresh mind. It also gives you a new approach to the problem, not just how do I make this work? When you're starting something for the first time, you're coding something new, your whole goal and mentality is how do I make this work? How do I get it to operate and complete successfully? But the second time around, you're looking at maybe how do I make this more efficient, or how do I make this prettier? How do I make this more maintainable? The comparison I really like, actually, that I just thought of is Maslow's hierarchy of needs. When you start at the bottom, it's things like food and shelter, your base level needs for a human to survive. That's what you're doing when you're writing code. How do I get this to work? I just need it to work. But once you've gotten it to work, you cover that baseline. And then when you start over, you're now not thinking, how do I get this to work? I know I have a working solution. How do I make this better? How do I adjust and look at my new level of needs? The next thing on that pyramid, if you will. And if you don't remember Maslow's hierarchy of needs, you do a quick Google search. It'll show you this nice little pyramid of things. You can also relate this to writing and then editing a piece of content or book or something. We do the same thing in coding. We write something, but then we don't really want to scratch it all because after all, we're sold on this solution. It works. We love it. It's our code. But now you're hacking away at that. You're totally getting rid of what you've already done once and forced to reevaluate the problem and write it again from scratch. You're not holding on to bits of that code. No, it's gone. Try it again. Do something new and fresh. Obviously, the author adds that you don't want to write literally everything twice. You don't want to write large programs and everything twice. This is a heuristic. Apply it intelligently. Pick and choose the things that maybe you're going to be maintaining or supporting for long periods of time, or things that you want a wide variety of developers to access and be able to make code improvements on it later on. Pick and choose which things are going to be most critical. The next thing that the author talks about is there is something to be said, especially as a novice, to get more experience and to just write more code. There's no greater teacher than experience, right? For instance, the author offers that the first 100,000 lines of code is usually a good baseline. There's a similar thing in music, actually. The study that's often referenced that you don't master a skill until you've devoted 10,000 hours of practicing your instrument. Whatever instrument you happen to choose, you have to devote 10,000 hours of practicing it before you're considered to have mastered it. This is similar to a programmer writing code. You have to write so many lines of code before you get comfortable and before you master it. Writing everything twice falls into this methodology of the more you do something, the better you get. Now, you might think, okay, but why couldn't I just tackle new problems and write more code by solving new and different things rather than doing the same piece twice? But the author makes the case that solving the same problem repeatedly is actually really beneficial for retaining knowledge of patterns that you figure out. So this isn't just an exercise of how many problems can I solve, how many lines of code can I write. You're looking for patterns in development. Okay, when I connect to a database, I do this step, this step, this step. Or when I do this specific calculation, you're looking for those consistent patterns that are very repeatable. Write those multiple times. Get to a really efficient, streamlined, fast written piece of code, and then you can reproduce that problem. For instance, connecting to a database, you're going to be doing probably the rest of your development career. Why wouldn't you make that bit of code as easy, as quick, and as efficient as you can possibly write it? Even if you're solving the same problem over and over, that can help you find those patterns. Another couple of options that the author talks about in this article is the time crunch heuristic. When you ask someone to estimate a project, they say it'll take 4 weeks. Now you alter the constraints on them. If your life depended on it, you have to finish in 24 hours. What do? The purpose here is to break your frame and your anchoring bias. You've just said something will take a month. Doing it in a day must require a radically different solution. The author says it's really surprising how often this works. Now, you don't actually have these constraints, hopefully, but the goal is to break down your constraints and your typical approach to problems and think outside the box. The last one is that becoming a better engineer is all about becoming a better pathfinder to solving problems. I have this path that I take to solve a particular problem. Are there alternate paths and routes or different things I can use to solve this problem? I find this overlap with graph data to be really interesting here. You're not just looking for a path through the network and a specific set of entities. Now I'm looking at alternate routes, maybe more efficient pathways, and different ways that I could get to that same result. Today, I walked through Neo4j's take on GraphRAG and the benefits it can provide to AI solutions. I also covered an article about improving software development through writing code twice. I'm at some conferences over the next couple of weeks, so I hope to provide an update here soon on an upcoming podcast episode about my experiences with those. As always, thanks for listening and happy coding.